Okay, this video is for less than 3 points. No, 3 points, yeah. 3 points 15 for review packets 3D. Problem number 10. A supermarket sells 2 cartons of milk for a total of $5. So 2 for $5, right? How much do you pay for 10 cartons? I don't think I have to to explain this one. B. How much do you pay for each carton if each carton costs the same amount? I don't think I have to explain for this one, I hope. C. Write the rule relating the number of n of cartons to the total cost C. So, okay. Remember the water problem? We have certain steps to do it. First thing is make a list, right? And then make a chart, and then what was the third one? And yeah, guess check generalized method. So we know that's 2 for 10, right? That means 4 for what? Right? 4 for 20, right? No, wait a minute. It's not 2 for 5. It's 2 for 5, yeah. Two cartons, which is n, we use n, and the C for carton. No, C for cost, n for number of milk cartons. So 2 cartons, $5, 4 cartons, $10, right? So it's 1 carton, it's 2.5. So what's the relationship, right? If you have n cartons, then it will be what, right? So that's write a rule, and that's the good way. The part D is this situation on example of direct variation or inverse variation, and explain. So let me just write the definition of that. Can I type this here? Okay. Okay, so the direct variation we use if the relationship is y equals c times x, we call it direct variation. Okay? Alright, this is the problem. C. Alright, I'm not going to do this. Let me just simply type it. No, whatever. So the direct variation means we have y equals cx. So if the rule looks like this, then we call it direct variation. If the rule looks like y equals c over x, then we call it indirect variation. So after you make a rule, if the rule looks like this, it is direct variation. If the rule looks like this, then we say indirect variation. How simple is that? Problem 11 is pretty much the same thing, but different word problem. The distance a car travels at the constant speed varies directly with time. Suppose the car travels at 55 miles per hour. Find the amount of time it takes to travel 330 miles. Okay? So it goes 55 miles per hour. So that's miles per hour. That's the speed, and we are talking about the distance, which is in miles. So if you have 55 miles per hour, if you go 55 miles per hour, wait a minute. We have h, that's the hour, and the miles, that's the distance, right? If you go 1 hour, of course it's 55 miles per hour. If you go 2, then it's 110. You see, there's a pattern, there's a rule here. So how many miles does the car travels No, 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 wait a minute. Find the amount of time it takes to travel 330 miles. So if this goes on and on and on, you're going to have 330. What would be the hours? That's the part A. Part B, how many miles does the car travel in 20 minutes? So we know 1 minute it goes 55 miles, right? That means in a half an hour, it will be half an hour. And the 20 minutes is the 1/3, right? 30 minutes is a half of 1 hour, of course. 20 minutes is 1/3 of that. So use this idea to find out how many miles would you travel if you drive 55 miles per hour in 20 minutes. That's part B. Part C. So that's A. Part C, how many miles does the car travels in 40 minutes? Well, if you find the answer from B, if you double it, that's going to be 40 minutes, right? Because if you double 20 minutes, that will be 40, right? D. Draw a graph of the number of miles traveled against the number of hours traveled. Draw a graph of numbers. So, okay, so we're going to have some graph like this. We only need a first quadrant, right? Okay. So that's D. Draw a graph of number of miles against the time, number of hours. We'll have hours here and miles here, and this is 0. And you put whatever you want, like 1 hour, 2 hours, 3 hours, and you can say the highest one is 330, so maybe we should go 400. So 200, half of that, 400 is 200. Half of that is 150. So yeah, and then graph the point. And E, find an equation relating distance d to time. So yeah, you're gonna get the line, and from that line you can find the equations, or whatever the pattern you find out over here and make a rule out of it. That's gonna be the answer for E. Problem 13. The graphs of y equals 3x and x times y equals 12 intersect at 2 points. Explain why 2, 6 and -2 and -6 are intersect points. Okay, again we have, you use the point tester. So y equals 3x and x times y equals 12. So we have 2 points, which is 2, 6 and -2, -6. So they said these are the two intersecting points. That means these both points have to satisfy or pass both tests. So we have first test, y equals 3x, and second test, x times y equals 12. I'll show you that the first point will pass both tests. It's easy. Plug that in. Y is 6 equals 3 times x, which is 2. This is true. How about, so you passed the first test. You passed. Let's work on the second test. We have x times y. X is 6 and y is 2. That is 12. So you pass both tests. So this point, 2, 6, is an intersecting point. How about this? So that's part A. Part B. Sketch the graphs of graph paper. Show the location of the intersection. Okay, so do that. You don't have to have a graph paper, but if you can just sketch it. Okay.